Hi everyone, the previous two protocols we have discussed, the simplest and the stop and wait protocol, were for noiseless channels. But noiseless channels are not practical because mostly the channels are noisy and they produce some error in our frames. But still you can use the previous two protocol if the amount of error in or if the amount of error in your channel is very less and you are okay with the ignorance of it. So in the noisy channels, the first protocol we are going to discuss is stop and wait protocol, automatic repeat request, or we can simply say stop and wait ARQ. The name itself is a kind of a spoiler, and this is the whole thing the protocol does. So to detect error, we have to add redundancy bits. And how do we do that? By byte and bit stuffing. As we have seen in my previous video, byte and bit stuffing, we add redundancy bits. So we can know that some data is lost or something. As the previous protocols have no way to identify, we can put numbers on frames. So that their order can be defined, and if one of them is lost, we get to know. So how this protocol works? In this protocol, the sender sends a frame, but also it keeps a copy of it. Then it starts a timer for that particular frame. It starts a timer is started. So if it receives acknowledgement, then it's okay and it sends the next frame. But if the frame is lost, it won't get a acknowledgement. So what happens in this situation? When there is no acknowledgement, the timer we started before expires. Timer expires, and then it resends the frame. As we number the frames, the acknowledgement frames can also be numbered. And the convention is that if we are sending frame say 0 and the receiver receives it, it sends back acknowledgement 1. That means the next frame required is 1. So it's one more than the frame number. Okay. Well, this protocol is still inefficient. Why? Because our channel is thick and long. So what exactly we mean by our channel being thick and long is, thick is it has a large bandwidth, and by long we mean the round trip delay is long, and the time it takes to cover the whole distance one way and back. And the product of these two is called bandwidth delay product, by which we can judge the efficiency of our protocol. So to finally explain, the easiest method, as I told before, is through flow diagram. Okay, so this is our sender and this is our receiver. And this is our time axis. So, and this is the frames. 0, 1, 0, 0, 1, 0. Okay, so it is pointing at this frame, so it sends frame 0. See, it starts at this point of time, reaches at this, so there is some delay in the reception and sending, so it sends frame 0. Then the receiver receives it, sends back acknowledgement 1, that is, it asks for the next frame. Then the sender sends frame as it points to this frame 1, but say it gets lost somewhere, frame 1 is lost, so there won't be any acknowledgement for it, so the timer of frame 1 will expire after some time. Timer expires, so this frame will be resent after this. Frame 1 is resent. And we get the acknowledgement of whatever the next we want, say 0 again, so this 0. Now there's also a situation, let's say we send frame 0 and instead of the frame the acknowledgement is lost. So still the timer of frame 0 will expire, and it will resend the frame 0, and the receiver will again send the acknowledgement. Sorry, this was acknowledgement. So this is the process that goes on. If the frame is sent and received successfully, the next acknowledgement is sent. If the frame is lost, after the timer expires, the frame is resent and we get the acknowledgement. And if the frame is received successfully but the acknowledgement is lost, the frame is resent after the expiration of the timer, and then we get the acknowledgement again. So this is the process and it goes on. Okay, So yeah, as you can see, this takes time, that sending the frame, then waiting for the next acknowledgement. That's why the efficiency of this protocol is less. To improve this efficiency, we will be using the concept of pipelining. That is, before we had to wait before sending the next frame, but in pipelining we will send the next frame before we get this acknowledgement. So before we receive that our previous frame was received or not, we will send the next frame, and we can do this parallelly. Okay, so that's all for today. See you next time.